Okay, so today's miscellaneous topics are going to be on Java Applets, an overview, and then also on connecting databases and with the HTML and using databases online. If we get there, we'll see what happens. But I really want to get through the concept of Java Applets. Next week, as I previously mentioned when I wasn't recording, we're going to see HTML5. So next Wednesday is all about HTML5. The following Wednesday after that is about the final exam review. And then the final, it will be on the following Wednesday, just to recap that point. Okay, so Java Applet overview here. What are we looking at? Well, we're looking at the ability to embed applets or programs inside of HTML. Works with HTML5, HTML4. Actually, kind of the interesting thing about HTML5 is not very much of a difference. It's HTML4 plus a few video options and some few formatting stuff. In fact, about an hour, you could probably learn everything there is to know about HTML5. Not a significant change. Although, if you look at the media, you look at the news, it seems like, oh, that's the best thing since sliced bread. I don't know if it really is, but so. And another interesting tidbit, so recently I started experimenting with Windows 8 and with the app development with Visual Studio 2012 and Blend and some of the tools that are available for that, because I'd like to teach a class here at ITU on that eventually. The app development stuff, a lot of it's done in JavaScript. So taking a JavaScript course is not a bad idea because it'll help you actually with Windows app development. So we have HTML, we have JavaScript, we have regular old languages being used. We do also have programming language interfaces to it, but you can transfer a lot of web development skills into there. So not a bad idea to get up to speed on JavaScript. And now we've gone through a little bit of it in this class, but this is not a full JavaScript class, it's an HTML and CSS class. So let's see. So what are we looking at here in terms of the applet concept? So we've been looking at JavaScript. That's a totally different language than Java. Java is the full version of the programming language. And if you're interested, I am teaching object-oriented programming in Java next term. That will be the beginner course, and it will be offered on the weekends. So you'll have the opportunity to take it if you're interested in this. Applets are how we bring it into websites and how we bring in Java, well, one of the ways that we can bring in Java into HTML and CSS. So I'm not going to get into a lot of Java programming today. Instead, I'm going to get into how do we use the applet with the HTML and CSS. Just the same thing we kind of sort of did with JavaScript. So designing the goals, the features. One really good thing about it is it's platform independent, which JavaScript is actually browser dependent. The platform that runs an applet is actually the JVM. You install the JVM on the target platform. You go to the web browser, you go to a web page that uses an applet. The applet gets downloaded to the client's machine, runs on the JVM that's on the client's computer. It doesn't run from the server, which is different from the Java EE technologies where the program is actually running on the server and you're getting the output on the client. So it's kind of interesting how that varies a little bit in terms of the concept. And we know JavaScript runs from the web browser. And so the web browser support for JavaScript and document object model and all of the other components is really what the key is. And a lot of you have discovered that you have different functionality with different browsers when you've been doing your assignments. And I encourage you to upload those assignments before the 14th. You have plenty of time to do it between now and you can spend your Black Friday uploading assignments if you want. I don't think it's going to be that busy around the EMS, but we found out, or a couple of you have found out already, that some of your websites don't load in Firefox or they don't load in Internet Explorer. They don't look the same in certain programs. Well, that's true, and unfortunately that's the reality, because it's the browser that's supporting the functionality. Even HTML and CSS looks different. And it's not that it's not cross-platform compatible, it's browser dependent. So Chrome's going to look different than Firefox, it's going to look different than Internet Explorer. JavaScript actually varies as well because it's the browser support for JavaScript. In applets, it's not the browser, it's the JVM that you've installed on your computer. Nothing to do with the browser. So you can actually, people have taken this route because you can actually get more consistent behavior. It's going to work on every single browser. The only problem with this is that the user has to install a JVM on their computer. So you get a little warning. It says, hey, Java's not installed. You need to install Java in order to use this. That's not JavaScript. That means that they're using an applet or they're using some Java technology, probably in the form of a small applet, I'll talk about that in a few minutes, to generate the dynamic behavior that's being performed, and it's integrated along with the form, and it's or along with the interface or the video that's running, and the user basically needs to install the JVM in order for that to work. So design goals and features in terms of the portability, secure, simple, object-oriented. I would say secure with a little caveat there. You're giving your code away. JavaScript, you're pretty much giving it away because it's all text. You know, if you've ever viewed the source of a document, you can see all your JavaScript code. Well, when you run an applet and you put it on the website and the user accesses your website, they download the applet. So you're giving the code to them, essentially. They can run it as much as they want. They can decompile it. They can do whatever they want with it. So not so secure, but Java itself has some security features built into it. It can't write to log files, can't change files. There's limitations to the applet that don't exist with regular Java that enable some higher level of security because it is being used over an internet website. So as a programming model, applications versus applets versus servlets is what I'm going to talk about today. And then the introduction to applets, libraries, components, and the applet tag that we'll see in HTML, and then the applet parameters and things. So we're using applets in HTML is pretty much the theme of the lecture. What's the history? Not owned by Sun anymore, it's owned by Oracle. But it was developed by Sun back in 1995. Originally designed for small embedded systems and electronic appliances. They used a version of Java actually for the BlackBerry. In fact, it's still Java run. Android is a Java-based operating system, which is why all the application development is done on Java. Printers, I don't know, little electronic devices all have Java engines on them. It's an operating system and it's a programming language all in one, which is kind of interesting. So it's different than some traditional programming languages. Initial attempts used a C++, but it's frustration due to limitations and pitfalls of C++ versus Java. Because in C++ you don't have a separate operating system, you have a regular traditional programming language. So Java offers you a lot more features and capabilities. So recall that C++ is C plus object-oriented features. Well, Java is Java. It's object orientation from the beginning. So the desire for backward compatibility led to retention of many bad features that were part of C. Not to cut down C. It's a good language, but for web development, not so, unless you go the .NET route, it's not necessarily meant for that originally. It was kind of after the fact, kind of design feature that was built into C++ versus Java that was built with the internet in mind right from the beginning. So design features from the Java white paper. It's supposed to be simple. It actually is. We have applets that are small little things of code that get downloaded. The smaller the better. One of the problems of using applets is because it does get downloaded and it ends up in the temp folders of the web browser. And you have to wait for the thing to download. A slow connection, a dial-up speed, not really efficient. On some of the faster DSL services we have now, people don't even notice they're downloading applets. In fact, if you go into the cache directory, you'll see a bunch of old applets and stuff, which takes up a lot of memory, actually, which is why most web browsers now have, clean the cache out, clean the temp files out. And you can actually save yourself a lot of memory by cleaning that stuff out. It is platform independent, which means not the browser, but the computer that you're using. So the computer could be a smartphone. Applets work on smartphones. It could be, it could be, I don't know, a MacBook, a Windows 8 machine. It could be anything you want, actually. And it's going to work as long as there's a JVM created for it. It is dynamic, creates dynamic behavior. It is distributed, so we can put applets all over the place and they can all work together. So can Java, other features of Java. Object-oriented, architectural, neutral, interpreted. Well, it's a hybrid. It's partly interpreted, partly compiled language. So when used together, it kind of creates the best of both worlds. C++ not interpreted. That's compiled. So it's fixed, not as flexible, not as dynamic as Java. So that's why another reason why Java actually lends itself better solution. Robust, portable, high performance, and secure. So note these are desirable features of any modern programming language, actually. So Objective-C and other languages fall in the same category. So Java is very popular, especially with internet-related development. Also, it's free. There's a JDK, and open source is also free, open source. So you don't have to pay for Java. You do have to pay for Visual C++ though, in Microsoft Studio. So I'm trying to get ITU on what's called the DreamSpark program, and the DreamSpark program would give you Visual Studio Professional, or Visual, you know, the whole thing. So for you guys who take Min Wu's class with the .NET and stuff, I don't know if he's providing you with the Express version or anything, or I don't know if anyone's taken that class. But it would be a nice feature for students to be able to download Visual Studio, especially for the app development stuff if you're going to get into that. So, not going to happen probably till summer before I offer that class. I have to go through some Microsoft training myself and get certified first. So it's in the makings though. So I think it has some potential. I'm not completely sold on Windows 8, but I sort of like what I see so far. And I like XP. I never liked 7 and I never liked Vista, but 8's not too bad. And if you've played around with any of the tablets that have the RT on it, the runtime version of 8, it's pretty slick, actually. But there's a full operating system. Underneath 8 is 7, essentially, and underneath 7 is XP. So it's nothing you're not familiar with. So, has anyone upgraded yet? No. You're not going to upgrade your computer in the middle of a term, probably, anyway. Not only that, but it sort of costs money to, mess around with computers and upgrading. So, although you can evaluate it for free 90 days, unfortunately, after 90 days, your version expires and it doesn't work anymore. But if you have an emulator, use emulation software, you can possibly do that. Anyway, back to Java, or Java Applets. So in terms of it being simple, the syntax is very basic, very C++-like. Very easy to transition for programmers. Removes any confusion and rarely used features that don't exist in some other language, like pointers and stuff like that. And so, actually, overall, Java is an easier language to program in than C or C++, only because it's, I want to call it a higher level of abstraction, but it really isn't. It's at the same level. They're both the same generation. I call them like 3.5 generation in terms of programming language hierarchies. But Java, some students find it a little bit easier because it has automatic reference counting, automatic garbage collection, automatic memory management for you, where C++ is a little bit more manual. So that's why a lot of people like Java. Not that I'm selling my Java course next term, but you might consider it. It's not a bad language. If you don't have a programming background, and some people taking this class might be transitioning into software engineering or computer science from other majors. If you don't have a programming background, Java is an easy language to learn as your first language. So, and you can become pretty proficient in it very quickly, actually. So, and it'll allow you to become more proficient as a web developer because you'll be able to create applets and things. So in terms of the object orientation, it's more object-oriented than C++. It's pure object orientation. Everything is a class, not an independent feature, which we have in C++. So there's a lot of argument out there that Java is purely object-oriented, where C++ isn't quite there. And it's also robust. So lack of pointers and memory management and all the headaches of C++ makes it a little bit easier to program in Java, per se. So it's also platform independent, architectural independent, portable. I've talked about a lot of these features so far, so I'm going to kind of skip through it. This is the PowerPoint lecture number 12, if you want to download it and read it at a slower pace. But we'll just take a, kind of a breeze through this. It's not really a sales pitch on Java, but I am giving you a sales pitch in terms of the lecture content. We do have a platform independence. We actually do have compiled versions. So to compare JavaScript with Java, Java is a compiled language. Even applets are compiled. So we have a .class file. We take the .class file, we upload it to the website, just like we do a JPEG file or an image file. And then we load the JPEG or the .class file or whatever it is we're loading in terms of content into the HTML page using a tag. So we have a reference to this class object, and we can actually set properties about the class. As an example, how big to make the window, how long should it stay, should it load automatically. There's a lot of actually different parameters that are associated with loading the applet that I'm going to get into in a few minutes. But an applet itself is just a special form of a Java program, and it's downloaded with the page, just so you know that as well. And JVM is embedded in the browser. Well, the call to the JVM is embedded in the browser, but the JVM resides outside of the browser. It's In fact, some people notice like a little coffee cup that shows up in the lower right-hand corner of the screen. It says, oh, and then you can see in the control panel, you can see Java in there and Java JVM stuff in there, all the parameters that are associated with that. So it's not really, it has the illusion that it's embedded in the browser, but it's not really. It's called outside of the browser. And there's no implementation dependent features as well. And it's also portable. It's dynamic, interpreted, and high performance. Distributed, multi-threaded, and secure. So I'm going to kind of flip through this because it is turning into a sales pitch. So let's look at the models here. So Java applications are the standalone programs. That's what you basically create to assemble an Android app or to create a program that's going to run on a computer, on a desktop interface. Then the applet is the web version of it. It's the same thing, but instead of extending from object, you're extending from applet. And so you're inheriting from an applet, which means you get the base foundation for the definition of the applet. And then you put your code in there. So you can take programs, convert them to applets, applets convert them to programs. Actually, it's kind of tricky in terms of the UI, and some components aren't supported and some are, such as an example, Swing or Abstract Window Toolkit. You've got some variations in terms of what you can do in an applet versus a program. If you're not familiar with those UI components, don't worry about it. That's what you'll learn in the Java class if you take it. But you do have some limitations, but Java applets provide you with the client-side programming. So you compiled, so the applications to compare it must be compiled. They both must be compiled and then distributed, executed via an interpreter. So you compile also the applet code, and it's downloaded as part of the web page, and then it's executed by the JVM that's embedded or called from the web browser. We also have what's called the Java EE, or Enterprise Edition, that gives us servlets, and that gives us beans and other Java components that run from the server instead of the client. So one way to do it is to put it into an applet, send it to the client. You're not going to connect to a database that way because that applet is not going to hold your secret password and admin name that's going to do anything. And you have security limitations, as I mentioned before, because you're giving the code to the user. If you don't want to risk that, then you put it on the server and leave it on the server, and then you can take that applet, not really because it doesn't have a user interface to it, but take the code or the logic that you put in that applet, convert it to a servlet, load it from a server. You load it from a server, here's what happens. The user connects to the server, downloads the web page. The applet or the Java code is still running, but it's running on the server instead of being downloaded to the client and running on the client's machine. It's running on the server, and usually there's only one instance of that object running on the server. When the client goes and connects to the server and they're downloading an applet, every single client is downloading that applet. If the applet's big, that's a lot of web traffic. Every single connection is downloading their own copy of this applet. And it's not only taking up room on your computer as a client when you download it, but you've got the transfer. You've got all that data that's going back and forth. Time consuming. So applets are slow, naturally. They slow down the network. So people kind of stopped using them for a while there and said, well, do we really need to, create that bottleneck with those clients who are downloading, because everyone's going to download it. Why do that? Just put it on the server. Nobody has to download it. They just run it from the server. So then when servlets came out, I went, oh, the servlets are a little bit more difficult to put together. They're like little applets. They're an applet kind of substitute. So the server is loaded with Apache or with regular server software, which the HTTP protocol needs to use anyway, so you've already got that going. So you load up the server engine, you load up a manager for those servlets, but if you're using RMI or if you're using something else that's associated with the enterprise toolkit that you have available to you, you're loading the Java server component so that you can load your servlets in there, which are kind of like little programs, like little applets that are just running some functionality. And then they're worker bees. So those things, and they're sort of similar to beans, but beans are components that you can apply towards database connections and, FTPing and music management, and you can have them all do separate jobs. So what you're really doing is taking the applet concept and putting it on the server and creating a bunch of little ones, little programs that are doing a bunch of stuff. and then you can distribute them out over multiple servers. And then when the client connects to the server, they're only using one instance that's created. So each client who comes in is not creating a new instance of that servlet or that applet or anything, not downloading anything. It's all being managed by the server technology, which is another way of going as well. So unlike JavaScript, Java is a fully featured and extendable library where you can put in third-party tools and library options and stuff. And the Java and the APIs have become industry standard. There's a lot of Java support out there for everything. And the language definition is controlled by Sun. Well, substitute that in, put Oracle. This is an older lecture. And it ensures compatibility. Actually it does. It's pretty compliant these days. And the language interface standards and behaviors are useful for classes and libraries and other routines. So the Java servlet down here provides a similar capability on the server side, an alternative to CGI programs, which fully integrate a web server. So a lot of people are going to say, I can't use a C++ program on the internet. Yeah, you can. No problem. You can, actually. You have to go through a CGI. So CGI stands for Common Gateway Interface. So before Java came out, when we had C and C++, people created these programs. Well, they're executable programs run on a Linux server. You write the program, you put it in a CGI bin directory, and then you install the gateway software. And then the website that you're running goes and looks for that file in the directory and runs it. Runs on the server, doesn't run on the client. It's very similar to this brand new, the more modern day Java EE version of this. But in essence, it takes away the client control over it, and it takes it so we're not giving the code to the client. It's running on the server. Problem is that every time someone comes in to run one of those programs, they have a new instance or a new thread actually that gets created. So it creates a lot of server traffic because now you have for every single client who's connected to the server, you have a thread opened up and you have a running program for everybody individually. So you have 100 clients, you have 100 versions of Hello World running, which not too efficient. So instead of it bogging down the communication channel between the server and the client, now it's just backlogged and overworked the server. So that's why people like the Java EE route, because it's a little bit easier to and more efficient, essentially, to design it. All right, so the applets. So important point here, Java applets and applications look different. They do look different. They have different UIs to them, and they have different components. So if you want to define a standalone application, make an application requires a public static void main function, very similar to C++. And if you want to embed the code in a web page and make an applet out of it, then you run a public void paint, public void integer. So you run different methods. So you embed different method calls in the code to write to the browser window, to paint to the screen. And you can define dual purpose programs, but it's kind of tricky. A lot of people don't spend the time doing that. Instead, they'll have one version of it that works through the web browser, one version of it that works on a standalone computer, two separate applications. So as with JavaScript, security is central, and by security it means an applet you can't download an applet that's going to go through and erase your hard drive, or that's going to go through and read and write to files, or gather a bunch of information and send it out. The applet is very restricted in terms of what it can do. And you can set a security policy file with your JVM, which most people don't do. They just leave it on the default. That even heightens that a little bit further as well. If you do that, then you're guaranteed not to have any weird side effects occur. So the Java applet is downloaded. The bytecode is verified by the JVM. It verifies it to see if it contains bytecode, opens it up, reads it to the local disk. And then the applet itself can open a window. But when the Java logo is logo to prevent them from being disguised as other Windows systems or other Windows passwords or stealing password things. So what ends up happening, that's where you see that Java logo that appears on the bottom of the screen. It's basically, originally it was designed to tell you that, hey, it's a Java applet that's running and it's safe, versus something's running on my computer. What is that? It's a virus or something. So it's actually running under a security policy, which is good as well. And Java applet, it is not allowed to connect back to other servers except the host. So the applet itself can only communicate with the host it came from. So it can't open up read-write files on other computers or on the host. only on the server, and then it can also not communicate with other servers. So you can't create an applet that's going to run like a virus in terms of that malicious activity. And then there's a this secure exception environment is called the sandbox model, which is playing nicely in the sandbox, which means the environment is fixed for its purpose and its general functionality. So let's see, we have our first applet code sitting here, and in the first applet code we have this class. I just tried to make this bigger, but it wasn't, so we'll have to kind of squint and see this, or you can download its lecture slide set number 12. This is fully running Java code, so you'd have to take and go with Java C to compile it. But what we have is an import abstract window toolkit, which is what AWT stands for. And we're also importing applet because we're going to extend from applet. And here's the trick here, where we've got extends applet. So this is hello world, and this is an applet that runs, and hello world just prints something to the screen. And so what we're looking at then is some comments here, and then we have this one kind of class definition. It's called hello world extends applet, as we see here. And then we have public void paint, which is going to the graphics paint library, and then g.drawString, which is a method drawString for G, and G is the graphics library. You know, it's basically going to print onto the screen hello world 10 by 10. So it writes starting at 10 pixels and over and down 10 pixels. So this is the location where we're going to write it. So this is a kind of a Java applet that writes hello world to the screen. A lot of work for that, but if you put that in the website, put a tag there that says, you know, load this applet, it'll run and it'll print hello world to the screen. It prints it to the web browser screen, which is running inside of the web page. So it's inside of the HTML page where it's going to print that to the screen. So the library is here. So Java provides extensive library support in the form of classes. So we use the import here, which is the import up here, which is similar to the include in C++. And then the abstract window toolkit is for the GUI. For graphics is actually part of abstract window toolkit, and it contains the applet class here, the applet class. So you can actually create a window by extending window, an instance of a window, and then you can put in the window. You can actually make a program that looks like a Windows program, or it's going to look like a Java program. Stick it in an applet and load it from a web browser. So if you've seen some of those sophisticated websites, you know, they have like programs in them, and they're like a program. You go to this URL and it loads up this window and it looks like a program running in the form of an applet. And the applet has all of the capabilities of the window and the frame and the GUI components and the buttons and everything. So if you have a lot of functionality that you're trying to put into HTML and CSS, and it goes way and above what you want to do in JavaScript, and it's really it borderlines on an application, you use an applet instead. So it's the step up past JavaScript, is to go into the applet category. So here's our first applet here, looking at the comments. We have these comments up here, as I mentioned before. It works the same as in C++, and designates documentation commands, and then it can be used to automatically generate HTML documents for Javadocs as well. So if you take the Java class, I'll show you Javadocs, but there's a lot of IDE support for that nowadays. So Eclipse is an example. There's a button. If you install the plugins for Java, you have a button you press that says generate some Javadocs. Okay, well, what is that? You probably have seen it already. If you go online and search for different commands, you'll see these Javadocs come up. It's kind of like a standard format. You know, it's usually blue and white and black, and it's kind of a hierarchy of commands and stuff that are on there. So it's interesting, actually, how they all look the same. But you can create your own for your program, actually. This is a way of creating Javadocs is a way of creating a help system automatically. So here we have the class definition here, and this is just how to build an applet 101. It's not programming in Java today. So, but we are declaring a class. So the class declaration is going to come out with public here. It's a regular standard routine. We can actually leave the public word out and just go class. So just like function, we're creating a class, and the class is going to be representing an object, and the applet itself runs as an object. So we create an instance of that object inside of the code. So similar to C++, but then no semicolon at the end. Instead, we have hello world, which extends applet. So if we took off this extends applet, we'd have hello world that would run on an application instead. So it kind of demonstrates sort of the differences between an applet and an application. If the code inside of it works on both, just change the class so it doesn't extend applet, and voila, you have an application. So it's kind of easy to translate them back and forth. You can contain instances of data members and fields. So just like Java, we can declare variables and methods, or member functions or functions. So we can take all that JavaScript code, the data, the functions, put it inside of a class and run it from a class instead, essentially. Precedes the class, we have a preceding the class and the method declarations with public to make available to all programs. Public is the access method, and the access method by default is public. If we made it private, then we would have no problem running it, but we couldn't extend from it, and we couldn't do anything with it. It'd be sort of limited. In fact, we'd have to run it from within inside of itself, or within inside of another applet that it was embedded inside of. Public makes it available from the web browser, from the public itself. So there's no standalone functions in Java. Everything's inside of this class method. And it must be stored in a file, and the file name has a .java extension, so this would be called helloworld.java, if we were looking at that. So all applets inherit from the applet class, which is the Java applet, which is why we imported it up here. And then the default method includes init. So init is sort of like the constructor, sort of Objective-C-like as well. So init is called when the page is loaded to create initializer variables and default, or it does nothing really by default. In fact, if you don't put it in, this code doesn't actually even have it in here, then we don't have to worry about it. If we wanted it to do something, we say initialize. Well, get something from the form and load it into this variable. Get something from the page. Get something from the browser and load it into this variable or something. Initialize, basically, variable declarations and pieces of the code itself, which does come in handy. So the applet can communicate with the outer page. It can actually go and get something. And the applet could run embedded HTML code inside of it, just like JavaScript. A little bit harder to work with, though. Generally, when you're creating an applet, it's a standalone program that's running, not as much communication. So when people use applets, they're going to use it for functionality. So on the form, the users filled in everything. And then we're going to call the applet. When we call the applet, we're going to send it all the information from the form. And then we pass it in as arguments coming in when we make the instance of the form object that's going to run the processing on that information, and it's going to tell us whether we're accepted or declined or something. Or it's going to, maybe the applet's going to go ahead and assist with the credit card processing or something, or it's going to do something that's a little bit more complicated than what we want to put in JavaScript. So here we have the paint method, and the paint method taking on graphics G, which is G is going to be a variable declaration of type graphics that's going to be of the parameter for paint. So it basically calls the draw after init and then redraw after the above is obscure. So the paint method is overwritten to display text on the applet window. So now how do we get it inside of HTML? Well, we do this. So we embed an applet in the HTML code. So it includes an applet with the page. We can either use an applet tag, which is called the depreciated method, or we can use an object tag. So preferred for HTML4, also but not universally supported. It is actually now, and it's actually supported in HTML5 now. So the object tag has pretty much become the standard. The applet tag is the old-fashioned way of doing it, and it works actually in some browsers. So here's what the situation is. We have browsers that support HTML5 and browsers that don't. And so in the older browsers, most people would use the applet tag. You can still do it, and it still works in HTML5. So if you want to be safe, you can use the depreciated older style way of doing it, and then you're guaranteed it's going to work in everything. If you know the application is going to run from an HTML5 compatible browser that's going to work with that, then you're going to use an object tag, because that's going to give you a few more parameters that you can add, and it's going to give you a little bit more control over the running of that app. So it's the more modern day way of doing it. So what do we have with the applet tag? Well, it's the code that specifies the applet name, the height, and the width. And it specifies the window size. Because we're running a program inside of our page, it's going to run in a window, and we can specify how big we want to make the window. That's about all we can do with an applet tag. What's the name, where's the location of this file, and then how big do we want to make it. So the text between the applet tag is displayed. If unable to execute, then Java is not enabled if it's not able to execute. So sometimes the browser has settings on it. So what you can do is an alternative text message that says, and you'll see this a lot, you'll see the broken kind of little piece there, and it'll say Java is not enabled, or Java not installed, or some. So you put an alternative tag in there that says to the user, hey, install Java, which means we tried to run it, but we failed because Java's not installed. And then sometimes you can actually click on it and it'll go to the Sun site or Oracle site and you can install it. With the object tag, it's preferred with current versions, and it's run the same way. You just substitute the word object instead of applet. Because now, in more modern HTML versions, we have different types of objects that are more than just applets. So we can have objects that are video files, objects that are audio files, objects that are applets, objects that come in the form of other languages that are not necessarily, so provided extendability. So we're not guaranteed that this is an applet. Well, I don't know if it's really going to be an applet. It's going to be something else that's applet compatible or something that runs in a window. So we can load an object in there, actually. In fact, we can embed objects types for YouTube videos, for anything that's out there, actually. And I'll actually have an example of how to put that together, along with some sample HTML5 code for you for next week when we look at HTML5. But that's one of the new tags. That's one of the tags that's the most preferred method. And in fact, it didn't even start with 5. It actually started with 4. So, but it's more widely used now. Okay, so we have our page here. Here's our applet code down here in red, which we've been looking at here where it says hello world.class. So once we compile it, and I sort of left out the compilation part, but the text is the .java. We run javac on it. We compile it to a .java, from Java to a .class. This is the bytecode version of it. We upload this to the website. It is case sensitive, so the capital H and the capital W has to be retained. And we have to put the .class extension on there as well. We have the height, we have the width, and then we have a message. You must use a Java-enabled browser to view this applet. So we have an opening applet tag and a closing applet tag. This would be opposed to putting the keyword object here. Opening object, closing object. And so the code is going to be equal to, and this is code, which means, well, this is runnable code, which means the browser is supposed to run it. And if the browser doesn't run it, we don't get the box that shows up. If the box doesn't show up, we're going to get this printed to the screen, which is kind of the way most people do it in terms of notifying. So here's another kind of version of it here. So the applet can be embedded within the HTML elements, just like any other element, useful for formatting and layout as well. So we have down here, we have the div tag, we're centering it, we have a table, and inside of the table, we're going to put the applet. So just think of objects and applets being embedded anywhere you want inside of the page, inside of any element. So you can use it with tables, with box. You can put applets inside of list boxes if you wanted to, or option selections or something, which makes it kind of interesting as well. And in terms of the parameters, we can give it a value if we want to call to it using the object document model. So you can specify parameters to the applet when it is embedded. So each parameter must have its own param tag inside of the applet. So we actually get the same thing with the object tag as well. Param name is name, value is Chris. Param name's name age. The value of age is 20. So we can create these parameters, and maybe these parameters that we're going to use are going to be some information from a form. So get the user's name, get the user's time zone right now, get the user's browser, I'm using Internet Explorer, okay, and get all this information and use them as parameters that's going to be transferred and used inside of the applet somehow. So And then specifying the name and the value, so we can kind of set this and get this in terms of the data that we're going to associate with it. And so here's another example here where we've added some applet parameters. So we have a string username, get parameter name. So integer user age is equal to integer.parse integer. This is looks like JavaScript, but it's actually Java. So, and then print. This is their applet code in here. So string message1 is equal to hello with the username. Well, get parameter is going to take it from the websites. So if we have name out here, and we say in our code, this name here, we only hard set name to Chris. But this could come from a document element, like name, the name label.text or something. So we can apply the document object model, get the element, the name of the element, get the text from the element, the text box. So say, enter your name, enter your password. And then the applet can go run it and see, take that information and run with it and do whatever to it. So in the HTML code, when we run the applet, we set the parameters. The parameters are our outer interface from the HTML perspective. And then inside of the applet code, this is the applet code here, inside of it we're saying get parameter. So what is a get parameter? Well, get parameter name. It's not passing it. So that's why I say applets are slightly different than applications, because we wouldn't do this with an application. Instead, when we ran the application, we put the parameters on the line, command line when we were running it, and we parse that in terms of the command line interface or the Windows interface. And we take all that information, we stick it inside. Same kind of concept, actually. It's just this is more HTML friendly. So we get the parameter name. Here we're going to, integer, parse integer, which works to get the parameter age and parse it in as an integer and assign it to user age. And we see we have data types now instead of variables. So now we have string, and we have an integer that's coming into this app that we've created, applet, I should say. So now we can print some stuff to the screen. So you can access parameters that are passed in from the HTML document. And get the parameter is the one. So we set the parameter using a param name equals name.text or something from a order number.text or something. And then the get parameter inside of the applet accesses the value of the parameters. So you have to know the name, and you have to hard set the name. So when you write a generic applet, you have to provide some documentation. It says, hey, this applet works with a username and a password. And this is what it's called. So set these parameters in your code. So usually when you see, in fact, a lot of people do this. You find some code you like, and hey, it's an applet. You can use it. Sure, why not? And then you look at the documentation, and it says, set this parameter, set that parameter. Usually they give you a template, or they give you a sample of how the tag is supposed to look. And the tag is sending the information that you need. So the object tag, generally you send the URL. So let's say, for example, I was going to run a YouTube video or something. I can send the URL as a parameter. So when the object tag runs, it creates an object on the screen that's of a generic form that's following a URL, and it's embedding the video right there in my page, which is really cool. So that's like the HTML5 way of doing it. So, or putting the applet right there in my page, and I'm sending it this information. So if the parameter represents a number, then we're using parse integer and parse float. This is where you have any knowledge of JavaScript. You go, oh, it's kind of similar to Java. It is. Some of the syntax is the same. There's not the same language. That's a little bit different. So Java versus C++. In Java, every variable and every method belongs to the class. So as in C++, default class objects have its own copies and its own data fields, thus known as instance variables. So I've been calling them objects and instances of objects. Each one of those objects has its own instance variables for each one of the pieces of information that it's working with. So as in C++, a variable is declared as static, that they are shared among all of the different classes. So we use a lot of class variables or static. If you're familiar with Java, you use a lot of class and static, kind of because you're not really making an instance of the object and doing stuff with the instance. Instead, you're just using the class as the object, and you want to run it from a class level as an applet. So it's a little bit different. Similarly, you can have a static method or a class method. So you can only operate on the class variables accessible from the class itself. So this scope is within the class declaration and class variables. So here we have a class math, and inside of the math we have a double pi. It's equal to 3.14, and then we have a double square root of, put a number in here to calculate the square root of something. So primitives versus reference types. So we don't have pointers in Java. We have references, and we have object references, and we can use those in applets actually and make the functionality a bit more robust as well. So primitive types are handled exactly as they are in C++, and those are the integers, the floats, the doubles. These are data types. So space for primitive object is implemented or implicitly allocated. So variable type refers to the actual data stored on the stack. Reference types, as in classes, are handled differently. So space for the reference object must be explicitly allocated using new. So we have to go, well, say new video, or new something, new image. So the variable refers to the pointer to the data, which is stored in the heap. So unlike JavaScript, we can use new in JavaScript as well. But we're using the browser memory to store that stuff. Unlike JavaScript, we're actually using the JVM, which is going to be managed a little bit more robust, a lot more memory capabilities. So if you're creating a lot of new objects and doing a lot of stuff, you might actually run a limitation to which the browser can handle in JavaScript, which makes sense to transfer it over to an applet kind of interface, because then you have the JVM a little bit more sophisticated, handling all the memory management, doing all the garbage collection for you, doing all the deallocation, and also the allocation, which is a lot better. So unlike C++, programmer is not responsible for deleting dynamic objects. JVM performs automatic garbage collection to retain unused memory. In JavaScript, nothing is deleted. So you can create a website that runs very slowly by allocating in JavaScript. And the longer the user sits there on the page, the slower the page gets. Because you're taking something that sort of works, which is why a lot of people don't use the object-oriented features of JavaScript, actually, because they're stuck with the limitations of the browser memory and the capabilities of that browser. Some browsers work better than others. Some will run faster because they have a higher memory footprint or something. So applets sort of solved that problem, because now you're running with the JVM. JVM is going to do all the garbage collection for you. So bottom line, long story short, if you're creating a robust application, lots of functionality, lots of variables, lots of objects, lots of calculations, lots of memory, put it in an applet. Easier, better, faster running. Although it's slower to start up with because you got to download the applet, you have more robust memory management. You have a lot more features that you don't get with JavaScript. If you put it on the page, run it from the browser, it's a lot of functionality for that browser to handle. Not so robust in the long run. Could be there's definitely a a bottom line where you have to kind of figure out, is this too much for JavaScript? If it's too much for JavaScript, you might want to kind of design it differently to take more advantage of things like the JVM or something. So Java only provides by value parameter passing, not by reference. But reference objects are implemented as pointers in the dynamic memory. So although you're doing by value, it's also by reference. So the applet itself will run fairly quickly. So resulting behavior mimics a by reference, although it is by value. So going back to kind of the differences between an applet and an application, the same thing occurs actually. You still have the same by value, but it's by reference, which is kind of interesting. So this is just a method that's taking on information from an array of objects. So Java libraries, the other reason why people like to use Java and applets instead of JavaScript, larger library selection. In fact, you have libraries that support real programming. JavaScript, not so much. You can import libraries and you can use libraries. In fact, there's a ton of libraries out there for Java, like JQTouch is an example. So your web page can have objects out there that are running through JavaScript that provide like a touch interface. You've got, obviously motif capabilities, for window abstracts and stuff. I don't really have very much though. Past a user friend, and then you got a million of those, and they're all over the place. So you find which one you want, you load it on your website, you call it, you say, okay, load this library and use this functionality. You're only using like one or two of them kind of combined together. If you take the Java route, you have the full Java library extensions, which gives you a little bit more capabilities, actually. Gives you a little bit more functionality in the end. So the string class automatically loaded from Java language as an example. And you have everything you have available in Java, well, 99.9% of everything you have available in Java are applications you have for applets. That's why I say you can create a lot more robust functionality in an applet than you can using JavaScript, depending upon what you're trying to do. So here's our string class with automatic string methods and array classes for array types. You have similar array capabilities inside of JavaScript as well. And Java provided extension libraries for data structures and algorithms, the java.util for vectors, dictionaries, calendars, hash tables. So Java and inheritance. Java does not have templates, not like C++, but it does use inheritance. So generic functions and classes are obtained via inheritance by the applet. In fact, when we created the applet, we inherited from applet. So now we're at the second level in terms of the hierarchy. So with inheritance, you can derive new classes from existing classes. You can inherit applets from other applets. You can actually use the same kind of, if you're familiar with object-oriented programming, you can apply the same concepts to applets as you do with applications. So you automatically inherit attributes and methods from the parent class. And the objects of derived classes can be used whenever a parent class is expected as well. So it gives you the kind of capability to mix and match objects. Every reference type is implicitly derived from the object class. So by default, data structures that contain objects, their reference types can be stored, or mixed and matching things all in one particular structure. So you can get as an example, and this is going to be a stack structure that's going to store a list of objects. And some of the objects might be strings, and some of them might be integers, or some of them might be pictures and stuff. So you can gather up a bunch of stuff, put it in what I call a sort of a dynamic array that's storing mixed and matched object types, and then use those objects types to serve up features to your web browser user. He's going to select from a list, and depending upon what the item is that they selected, do something with the item. So you run a file, open a file, run a video, or do whatever happens to be the desired functionality. So here's a rewrite, more robust version of our Hello World example. So this is another applet. This is a more sophisticated applet version called Hello World 1. A slightly different name here. So we have the random class up here in red. In fact, what's in red is the changes that were put in. So random class provides the method for generating random values. So let's say, for example, I think a couple weeks ago, feels like a couple months ago right now, we went through a dice example with JavaScript. So you can use, and we had the random number that we randomly calculated between 1 and 6 from 2 dice values. You could put the same thing essentially in an applet and run it from an applet if you wanted to. And that would be enclosed altogether, which brings up another point about applets. If it's all packaged together in one applet, it's easily portable to other websites, easily reusable. However, anyone who wants to can reuse it. All you have to do is have the code. So a lot of people put special parameters in there to prevent other people from using it. So you downloaded the applet, and in there was a password parameter. Well, you have to provide the password parameter. If the password is incorrect, then the applet's not going to work. So you can do little tricks like that to protect it, but once you've downloaded it and it's sitting in your web browser cache or somewhere on your computer, you're free to use it. It's yours. You downloaded it. So long story short, you're not going to put anything too sophisticated in there, but for rolling dice, if you wanted to do it, here's how you could use the random inside of an applet instead. And so here we have random Randy, which is going to be the name of the variable that we're going to put together. It's going to be type Randy. So Randy.next integer, where we're going to have a low and a high number or something, and we're going to randomly generate integers from this, which is not really playing the dice game, but it's doing something very similar in terms of randomly generating stuff. You can override the integer method and allocate or initialize similar to a constructor and create new integer values and stuff. So down here's the code that you would use to actually put it in the browser. Applet code looks the same. In fact, when you start looking at applet code, most people just cut and paste and put the applet code in something and say, just change the name of the app and change the size, and you can pretty much reuse the same tag for everything you're doing. Applet behavior. So recalling that the integer method is called when the applet is first loaded. So using it to initialize variables and objects where you can initialize the parameters that you've set for the applet in the applet tag. And then the print method is used, it's called immediately after that, because what we're doing with an applet is we want to print to the UI. So it's all print focused. So we want to be able to display something to the screen. So after calling init and whenever the applet needs to be redrawn, the print method actually goes. So after the window resize gets obscured, so which means the user sits and refocuses or resizes the window, then the applet will reset itself and reprint, redraw, which is nice. So when the paint is called, it's given a default graphics object. In this particular case, we can have a string message maybe, and we have an integer x and integer y. And we can also run a method to set the color, passing in a color value. And then we have the color, so we have color.red, color.blue, color.black. Set it different, so there's a colorful version of the Hello World program where the colors are going to be set ahead of time, and then we're going to call it down here, get a random. So we're going to use a random number between 1 and 4, and we have 4 different colors. And so we're going to randomly set the color of something. Given what, it's kind of senseless, but given, the g.set color to colors, and then it's going to be color 1, color 2, color 3, or actually in this case black, red, blue, or yellow. So this is another way of creating dynamic behavior. So why would you want to do that? Well, make some dynamic, some random colorness that shows that. Well, it could be pictures. Actually, the better application here is it could be ads. Randomly putting up a choice between 1 and 20 ads or something, and then each one comes up differently. So it would be nice. So you can store colors in an array and then change the drawing method with a set color. Well, you can put ads or images in an array as well. And run the same thing. So parameters and applet dimensions. Also recall that you can specify the HTML document using a param tag and access the parameters based on the name using the getParameter method, as we've seen. You can also access the dimensions of an applet using the dimensions object. So dimensions dim get size. We can get the size of the applet or the object that we're using and then change the size, or I don't know, use the size to paint something else on the screen around the applet or something. So then you can access the applet height via dim height, the width via dim width. So you can dynamically actually use the object and adjust its parameters. So here's an adaptive hello world where we're getting, so we have the get parameter here. It's accessing the values of the parameters. Here we're specifying the number of references in the web page that we're looking at. So get parameter dim, number of references over here. Then it's going to be get size. So it uses get size to get the dimensions, pick the random coordinates of the text within the object, and then count something up. So the code here would just basically using dim.width and dim.height that we're getting from the get size. So we're going to take x and y and have it equal to a random height and width. So you can have your applet, as an example, float across the screen because we're changing the height, width, or the location. So if you've ever seen those little funny little things that float across, you can easily do that in the form of an applet. It's an image that moves across the screen or comes up and down and has a little, kind of functionality to it. You don't have to use Flash for that. Actually, you can use it with an applet. Actually, in fact, you can do it in JavaScript as well. It's not too bad. So applet graphics. So in addition to displaying the text, you can also draw figures, graphic objects. So we can draw a line. So instead of just drawing and putting text, we can draw a rectangle. We can fill a rectangle, draw an oval. all of the different methods to draw graphic objects on the screen. Not to be confused with OpenGL and not OpenGL compliant. However, there's packages to give you OpenGL components if you're interested in that, to draw true graphics, OpenGL related graphics. But we have basic stuff in the standard library. So here's an example of drawing a red circle inscribed in a square, and then draw random dots, or dart pricks. So in counting the number of dots inside versus the outside circle, we can estimate the value of, we can figure out what we're going to do here in terms of the radius of the circle and estimate out where dots are and stuff like that. So we could easily do this with, other types of approaches, but it allows us to basically use a get color here, draw a line. So you're going to draw a line, let's say, around something. So init method here creates the random number of generators and gets the parameters. So here's the init method, actually runs as the constructor or the initializer. And then in paint is going to draw the circle on a bunch of random points. So here we have the get color, fill oval with the circles, essentially that we're going to get for the size, depending upon what size we make it of the oval itself. And then here's the code embedded in the web browser. So you can actually cut and paste these examples, put them in text files. You have to compile them before they'll work. After you've compiled them, which means if you're going to compile it, you need to download the SDK. So you'll need both the JVM to run it, and then for the computer that you're actually going to create the .class file on, you have to download the SDK, or the JDK, I should say, and use Java commands to compile it. And it's actually really easy. In fact, if you use Eclipse, you can have a menu to actually write and GUI interface to actually do all this. Java actually supports double buffering, so note that the paint is called every time the page is brought to the front, which is interesting. So we have the view that's being refreshed automatically. Of course, we don't get that with JavaScript. It's only done with an applet. So in current versions of the Monty, means that new dots are drawn each time the page is obscured and then brought back in terms of the front. So waste time redrawing, the dots are different each time the applet is redrawn, especially if you're using random, your dice are going to change. So if you've ever seen, actually, as a user, you probably have seen this behavior. When you put the screen back and you refresh the screen, or you made the screen from minimum to maximum, and all of a sudden the values are changed. Well, what happened? What redraws automatically for you. And if it was doing something randomly, it's going to show a different picture. Or it's going to show something that's different numbers or something. So the double buffering approach works by keeping all of the screen images. So keeping an off-screen image and then reloading the off-screen image so you can get consistency. Otherwise you have that side effect that occurs. So the init method, which is called when the page loads, draw the figures on a separate off-screen graphic object. And in the print method, which is called whenever the page is brought forward, simply display the off-screen image on the page. So you're double buffering, which means you're taking and keeping a backup of what was there, just in case the screen gets reprinted, and you can refresh it with the new information. So here's the buffered app, which is basically doing this for us. So in the init method, when it's called, the page is loaded, and the initial information is set. It does the draw to a separate off-screen graphic object, and then it loads the off-screen graphic object when a redraw, when a paint occurs. So the paint is called after the init, and whenever the applet is revisited. So note, don't see an image in the progress. You can just basically, it just changes automatically for you. So here's a better buffering technique. So if you want to see an image as it is drawn, so you must be done in the paint method. So paint is what's called automatically. So a long story short, and just to recap this functionality for you, we have different methods that occur at different times in the object lifecycle. So when the page is loaded, we have the init that happens automatically. When the screen is painted, we have paint. So anything that happens with the browser that causes the applet to be reloaded, the paint's going to happen all over again. So we can actually use that to our advantage, or we can work around it if there's a problem with what it's doing. And the buffering technique is a workaround. So if when it's first loaded, the paint draws the graphics to the screen, also creates the off-screen buffer, which we're calling the double buffer. So on subsequent repaint, simply redraw the contents of the off-screen buffer again. So this is just an upgraded version of it that's going to do an else down here that says if off-screen image is null, meaning we don't have an off-screen image, then create one. If we have one, then paint it to the screen. So GUI elements in applets. So Java has an extensive library support also for the GUI, and so it has elements that corresponding to HTML buttons, text boxes, text areas. You can actually create a GUI interface that looks like an HTML page inside of an applet. So you don't know if it's an applet, you don't know if it's an HTML page. Actually, you can hide the window and it can run like an applet, although it looks like an HTML page. So you can hide the fact that it's an applet actually. Each element must be created and explicitly added to the applet. So here we have a name. It's going to be a label. We're going to add the label. We're going to have a name field that's going to be a text box. As an example, we're going to add the text box. So by default, the GUI elements are placed in the order that they're added, so we can have different layouts to fix it. So the elements can be moved to the next line to fit. So if we have different layouts, then we can wrap the elements. We can position the elements in context with other elements, so that when the page gets bigger or the page gets smaller, the GUI looks consistent and is in the right order. So here's examples of creating text boxes, and we have some text boxes that we're going to define in the beginning, and then we're going to add them to the GUI. So we're going to add them to the window and basically position them. So the best way to see this is to actually download the code and run it yourself, actually. You'll get a feel for that as well. So we have different layouts that are supported, and believe it or not, this is what you get with applications as well. It's the same abstract window toolkit that you're going to get with application development. So if you're familiar with Java, it's a really easy transition into web development from application development, because you can create a web version of that same application using the same components, essentially. So our GUI layout here provides several different classes for controlling the layout, and the flow layout is the default class, and border layout allows you to place the elements around the border of the applet on the screen itself. And then we have the panel that contains numerous other elements that are associated with it. So we also have event handling in applets, and it's the same kind of event handling that we have with HTML, but it's more sophisticated. We actually create what's called an action listener, and we put the action listener on the items, and then we see, when an item occurs, when the action is caught from the listener, we do something. So here, in order to handle the events of a text changing, a button clicks, we can use a delegated model here. So you must supply the class that implements the action listener interface, and then it extends applet implements action listener, which means we're going to put a listener on the item. So each source element must be registered with the applet and must actually be part of the listener. So we have here a dot button is equal to new button, and the button's going to have click to generate dots, and then dot button dot add listener, so add action listener. So it can be on click event, so on a click do something. So you must have an action performed, and here we have an action performed method that's going to take the action. So if it's on a click, if it's a double click, if it's on a hold or a drag, anything that the user could possibly do in terms of the actions that are defined. Then we're going to get the source, and if the source is equal to the dot button, then we're going to draw dots. We're going to run the draw method. So action listeners allow us to add the event-driven behavior to the GUI components from the applet. So they work inside of the applet. You can't put an action listener on something that's outside of the applet. It doesn't work that way. So it's in a self-contained environment, and we're looking for activities that are going to occur. In regular old HTML and JavaScript, our action listeners happen automatically, and it's controlled by the web browser. So if it doesn't work, or the web browser doesn't support it, then you can put it into an applet, and it's guaranteed to work, because you're controlling the action listener on that. So you can get more reliable functionality, is what I'm alluding to, if you use it from within inside of a Java applet versus in JavaScript. Sometimes you can actually, predict certain things and have certain behaviors actually occur. So in an unexpected way. So, okay, so this is just the implementation of the action listener, where we've created a button, we've put the listener on the button, the same code we saw before, and then down here we have the method to perform when the action listener is actually performed. So here's some applet examples. The Java Boutique has a lot of different sample applets. If you click on these, it's lecture number 12 and download it. You can see some of the different programs. Let's see. Let's see if one of these actually works. It's going to give me a warning. Internet site reports that the item you requested could not be found. Okay, so I don't know if I even have internet access over here, so we will see. It's possible that some of these examples have gone away, but you can find many different examples of applets on the internet. So combining Java and JavaScript together, there's no reason why you can't use both. In fact, you can actually combine other scripting languages in the same HTML page. So you integrate Java with the JavaScript. So you call the Java routine from JavaScript. You can control an applet from JavaScript, or you can access JavaScript and HTML elements from the applet. So the applet can call the JavaScript, and also the HTML. It can actually interact back and forth, as I was mentioning before. You can also create Java beans and Java archives or jar files. As I mentioned before, these applets can get kind of hairy when they're small little pieces of code. And you've got tons of little .class files, and you're going to move it from one server to another server. You got a ton of files you got to move. If you put them in a .jar file, it's all packaged together. And so you just upload the .jar file, and you load the .jar file, and there's all your functionality. It's a little bit easier to run. It's a little bit easier to manage as well. In terms of JavaScript versus Java, they do work together. So recalling that JavaScript is very good for simple tasks. JavaScript, if you're going to have a simple functionality, JavaScript would be a lot more user-friendly, a lot easier to do than creating an applet for it or using Java. So flexible data typing, primitive object types, fine for quick development. There's no strong typing that exists. Integration of HTML makes the layout and the control of the GUI a little bit easier as well. Not much library support, and only primitive data structure capabilities. So not well suited for multi-projects or object-oriented approach. Although you can program in an object-oriented fashion using JavaScript. It does work. Not quite as friendly, and not quite as feature-rich. So Java's better at complex tasks, especially graphics. So fully featured, more robust, extensive library support, classes, objects. You can actually even embed OpenGL in Java. There's libraries for it. So you can create some pretty sophisticated games, applications, interfaces that run from websites, which is not bad. And it can support large projects and interacting objects, where JavaScript doesn't really support interacting or distributed objects. So JavaScript's JavaScript. It's embedded or it's used in a web page. It's not working as an object normally. It's not interacting. So GUI layout is different and sometimes difficult. So integrating with HTML is not obvious. It's actually not what I'd call easy. So JavaScript's pretty easy for integration with HTML. Applets are a little bit more complicated to get the functionality to work correctly, but applets are still being used. Not the preference these days because they're slower in downloading. But if it's small and it's working, use it. And so people are still using it. Ideal, well, make use of the strengths of each language. And knowing that you can is the point of this lecture. So include applets in a page when needed, and don't include them when you don't need them. Allow communication between applets and JavaScript code, and use the best of both worlds. So calling a Java routine from JavaScript. And here we have, oh, that's an old browser, Netscape Communicator. Well, substitute that with Firefox. Allows direct calls to Java routines. Not all browsers are going to allow that, actually. Chrome allows a lot more than some of the other ones, actually. Specify the full package name of the routine. They can call it as a Java, as in Java, but useful for more routines that are not supported directly with JavaScript. So if you want to, depending upon the browser support, you can actually get the Java code to work through JavaScript by calling the methods or calling the objects directly. Not a feature and is not supported by Internet Explorer, but not a feature of every web browser. Some web browsers support it, some don't. Which again brings up that kind of concept of, write for one browser, say what browser you're supposed to use if you're going to use something like this. And here's a way of doing it with, document.write Java language. This is the Java language random we're actually looking at. So And calling applet methods themselves, and more commonly you want to include an applet in the page and control it via the HTML events and the JavaScript events. You can do that as well. So you want to draw dots instead of squares in an inscribed circle. So you can build a GUI interface into the applet and then require the tricky layout manager to be used to configure that. So instead, leave the graphics to the applet and control it through the JavaScript. So the applet's doing the functionality, the JavaScript's calling the functionality that's running. It's going to be run. So instead of call a Java applet method from JavaScript, you'd go document.appletName.method call. Most people would do that because you've got the full functionality of a real programming language like Java. You've got it loaded. Make the applet small, put a bunch of methods in there, call the methods. Then you're using Java inside of JavaScript, embedded in an HTML page. Then you got all the functionality you could possibly ask for. So, well, outside of doing it on the server. So this program of drawing the multiply revisited is the program of drawing the dots inside of circles. Don't worry about the theme of this, but it's basically running the methods. So in it is going to increment the random number generator and get the applet size. So which is what the previous example is doing. Drawing the dots and the dots on the screen to the off-screen buffer, and then painting them. So when the screen repaints, you're going to take the double buffer that you've got saved elsewhere and load it in. And then here's the new part. So here the HTML button controls the applet via JavaScript. So what you've got down here is a form, and on the form you've got a button. And what's the button going to do? It's going to call document.multi-applet, or whatever you're calling the applet, dot draw dots. So your functionality on your button inside of JavaScript is doing an action that's running a method that's inside of an applet. Do you have to make the applet? Nope. You have to load the applet? Yes. The applet has to be part of the page. So the applet code is kind of interesting. It's running from a class functionality. So those people who do Java programming don't like this because they go, how can you run a method when you don't even have an instance of that object available? It's all static. So you load the method from a class object that you haven't even made an instance of. But the class object, the applet, doesn't even have to be visible on the screen. It can just be in the page somewhere. And you run the methods from that. So you don't have to run the whole applet. You just run whatever method you want from the applet that you have loaded. So it makes modular code for you. It gives you bits and pieces of functionality that you can use outside of its intended purpose or outside of the applet from JavaScript. That is being used a lot, actually, because we have functionality. You're not going to put it all in the applet, probably, because it's going to run too slowly. So instead, you're going to load the functionality via the applet and then call the functionality inside of the applet from JavaScript when you're needed to do it. They filled out this form. Then maybe put the form checker in the applet, and the form checker goes through and checks everything and highlights everything and does all this sophisticated stuff real easily. And then you can reuse that code in multiple different projects. Every time you need to do form checking, you can run it from the applet code, essentially. Which is makes a lot more sense, actually, because in form checking, what do you have? Data types. In JavaScript, what do you have? Loosely defined object types. Everything's an object. So in Java, you have a lot more calculations you can perform and a lot more checking that you can do on the types and stuff. So it makes better use of form checking eventually. So, in fact, a lot of the Java applets do this. They go out to the, you put your address in there. You're trying to ship a package out. Well, why not verify to make sure the address is good before processing the order? So they'll have an applet that will run a method, and the method will go out to the United States Postal Service website, run your address through, verify it, come back and say, is this a correct address or not? Otherwise, they'll come back and say, something wrong with this address, your zip code doesn't match. Can you do that in JavaScript? Not easily. That's sophisticated. That's what I'm calling sophisticated. It's not really that sophisticated, but a little bit more complicated to do in JavaScript, because not only do you have to switch pages or open up another window, you're going to tell the user what you're doing. This is all hidden. If you run it from an applet method, you're just hiding it inside of the functionality that's in that method that you're going to run, that's going to perform that behavior for you. It's going to essentially do some sophisticated calculations. So our better interface here is allow the user to specify the number of dots in the text, take the text, send it to as a parameter to the applets, run the method from the applet that's going to generate the dots. So each click adds new dots. Our separated button is clear. So. Divide and conquer, where the control lies, affects the efficiency and usability of the applet. So you want the applet to be as self-contained as possible. Take advantage of the speed advantages and more advanced features of the applet capabilities, but if the GUI controls are in the HTML, then the JavaScript needs to overall control the page. So if you want the GUI to load faster, and you want the control to be, from the website itself, use JavaScript as the front end, use the applet method that you're running as the back end, and control the GUI through the JavaScript. It's going to load faster. Because it takes a while for that code to download. So a lot of times you see a website, and the website loads up, and then all of a sudden you see this little Java thing show up in the right-hand corner. It's not using any applets. Not that you see, because it's not using the applet for the GUI. It's using the applet for the functionality. So a lot of them are going to tell you, must have Java installed. And you're like, why do I have to have Java installed? Usually library websites, shopping cart websites, things are going to give a little warning, must install Java. And you're like, what do I need Java for? There's nothing having to do with any of the physical GUI interfaces. It's the functionality that's behind the GUI, and there's an applet in there that's running all this stuff that needs a JVM, and you don't have a JVM installed. So most people have it installed anyway these days, but that's where you see that little coffee cup, and you go, well, that page isn't running anything. I don't see an applet on that page. The old-fashioned ways, you saw this big old screen come up, and it was, it didn't paint quite quickly, and all of a sudden it fills in. Oh, it looks like a Java program. Not so efficient. The HTML is going to load faster. JavaScript is going to load faster. So also consider adding counters for a number of dots inside or outside of circles, counters that are kept in JavaScript. Have the applet keep track of the dots and instance variables. After drawing all of the dots, the JavaScript could actually access and count the display. Can't see the counts inside of a progress in Netscape or Mozilla. Have the applet update the HTML text boxes itself. A little bit tricky, but it's not too bad. Or you can also enter in more control to the web page. Applet can draw one dot at a time, repetitively, or it could be handled by the JavaScript. So the JavaScript can control the methods that are running inside of that applet quite easily. This is just an example. In fact, you can download, cut, and paste it. It's just keeping a counter, essentially. So we've got a counter variable, number inside, number outside, so we can keep track of how many dots are painted. So we can change the applet so that the method only draws single dots, control it by the JavaScript code instead of putting it inside the method, and have the method keep track of how many dots are inside and outside. And then here's a full example that's integrated into an HTML page, and then noting that you can utilize HTML tables to achieve the desired layouts as well of the elements. So you can use tables from HTML elements, JavaScript, and applets all together in the same page, and make the best of both worlds. So if you're going to have major functionality, put it in the applet code. Minor functionality, put it in the JavaScript code. Cosmetic, put it in the HTML, so you can draw tables and stuff with it. You can also use other scripting languages on top of all this stuff as well, which is what most web developers are going to do. So accessing HTML JavaScript from the applet is also possible. What I'm talking about is taking from the HTML page, we were accessing the applet in those previous examples I just went through. We can also do the opposite. So it's possible that the applet to access elements in the page requires the JS object class. So not supported in every browser. This is an old browser example from Netscape. Is Netscape still around? I don't think they are. I've never seen a Netscape. I haven't seen one in about 20 years. So I always think of Mozilla when I think of Netscape, and I always think of Firefox. But I'm not really quite sure that's a fair upgrade or a fair historical line of events. But this is the difference we get with the object document model, which is actually going away because it's not compatible. Internet Explorer has a different object document model than Mozilla, which is totally different. It's not standardized. but we can actually do it using the document object model. This is when you have to use Firefox for our website. You cannot use Internet Explorer, or you have to use, and then if they're telling you have to use a particular, it's because it's using the object model of the supported browser, and it's probably doing some integration with an applet or some other language that's not supported in other browsers. So it's only going to work in one browser. So most people have this common notion that all browsers are the same. And then you take this class and you come back, no, all browsers are not the same. And so for anyone who's going to ask me, if it doesn't work, your assignments, some of your assignments aren't going to work in all browsers either. So you're going to find one that works in, and you're going to tell me, it works in Firefox, it works in Internet Explorer. And don't worry about all the other options, because it's impossible to make it work in every browser. And sometimes it's just not going to work in a particular browser. That's just the reality of it. So, and I'm sure, next week I'm probably going to get more questions. It doesn't work in this browser, it doesn't work in that browser. I don't want to hear it. I know it doesn't work. It's not going to work. So just tell me what you want me to test it in, and then I know what it works in. So actually, all I need to do is look at the code, and I can tell you if it's going to work or not, and probably which browser it might work best in, depending upon what you're writing, what you're doing. So here's an example of using a JS object. We can actually use object models. So here's a get window, get member, set member, which is what we're using essentially in an object interface. So some related topics that I'm not going to go over, but some related topics that work along with applets in Java is the Java bean that I mentioned before. So looking at reusable components, buttons, menus, packaged and reused, requires specific tools for compilation and packaging, and it's downloaded with an applet using archives, so we can put it inside of a jar file. So as I mentioned before, beans are generally used on a server, and we can load them up and serve them out through servlet technology. However, they can also be packaged with applets, they can be put in a jar file and downloaded to the client-side machine as well. So they're kind of versatile. They are nothing more than a different version of the applet from a different hierarchy. Same code, same functionality, same capability in terms of but it's what they're used for is kind of the difference. Jar files. So for applets that are comprised of multiple different classes, you can bundle them all together into one file. And it uses a popular zip file format that's called the jar. And you download it using archives or attributes and automatically unzip it by the browser. So it stays as one file, which is nice. It's harder, actually you can encrypt it, password protect it. It's harder to decrypt it, harder to look at it for some people. Maybe not for others. Depends on the sophistication of the user. So that is my spiel on Java Applets. So maybe some of you guys are more encouraged now to take the Java class. Who knows? You can still accomplish everything you want to a certain point with JavaScript. Java is actually better for some tasks than others, though. So I'm going to stop this video.